Hi guys, welcome to Attic Philosophy. Today we're going to be talking about possible world semantics. This is one of the biggest, most important concepts in contemporary philosophy since, I guess, the middle of the 20th century. It's got applications in logic, language, philosophy of mind, metaphysics, and it's even spilled over into AI, economics, computer science. So it's a super important concept. How are we going to go about understanding possible world semantics? Well, to break it down, first of all, we've got to know what semantics are or is, and then we've got to know a bit about what possible worlds are. Then we'll put it all together, and then I'll run you through some applications of possible world semantics in philosophy. Okay, so first up, what is semantics? Well, it's the study of meaning, but more specifically in contemporary philosophy, semantics tends to mean the mathematical theory where we try to tie a bit of language to something in the world. And usually what we're trying to tie it to is ultimately truth value. So we're trying to give a theory whereby if we take some sentences and some other information, we can calculate whether that sentence would or wouldn't be true in a situation. So probably the simplest version of semantics of this kind that you know about is the truth tables in propositional logic. Okay, so suppose we're trying to work out the meaning of a conjunction, P and Q, using a truth table. What do? Well, it's pretty simple. We put it in a table. Over on the left, we consider the two letters P and Q, and then we consider all of the different valuations. P and Q might be both true, one false, the other way around, false and true, and then both of them false. And then we consider what P and Q would look like under each of those valuations. So if they're both true, it's true, and in all the other cases, it's false. Okay, so there's a really simple kind of semantic. So it tells us that a conjunction is true when they're both true, a disjunction is true when at least one of them's true, a negation is true when that thing isn't true. And that's fine as far as it goes. But what happens when we get tricky stuff in there, like the quantifiers or the modalities necessarily and possibility, or even a decent treatment of the conditional if-then statements? None of that we can really make sense of with truth tables. What about when we get epistemic operators like somebody knows or believes that something? None of that really makes sense with truth tables. What if we want to give a kind of similar mathematical semantics that allows us to calculate the truth values of sentences, but we're interested in sentences containing this kind of stuff? Well, that's where possible worlds semantics is going to come in. Okay, so that's what semantics is, broadly speaking. What are possible worlds and how do they help? Possible worlds are basically just ways things could have turned out, ways our universe could have been. I'm sitting here talking to you guys, but I don't have to have been. I might have been lying in bed reading my book, or I could have been at work in a meeting. Okay, so there's a kind of a better possible world there where I'm lying in bed, and a worse possible world, for me at least, where I'm sitting in a meeting, and there's a kind of a pretty good possible world, for me anyway, where I'm sitting here talking to you. So these would all be different possible worlds. So these are like partial specifications. A possible world isn't just like me sitting there, it's the total of reality, answering every question yes or no. So you might wonder, well, exactly what are these possible worlds? And from the point of view of semantics, don't worry about it. Just, don't worry about questions like that. They are just, useful fictions or whatever. There's a whole metaphysics around what possible worlds are, and, we can do a deep dive on that. But for the point of view of the semantics, we don't need to worry. We just postulate there are these things, and then we do good stuff with them. Really, all that matters from the point of view of the semantics when we're doing classical possible world semantics is that the possible worlds are both consistent and complete. Consistent just means they don't make any contradictions true. Okay, so if I'm sitting here, I'm not also lying in bed reading my book, and they're complete. So basically they should answer each question. A possible world should say what I'm doing, if I exist in it. It should say what you're doing if you exist in it. and so on for every single thing that we could think about. It's going to give us a definite answer one way or another. Okay, so what does possible world semantics look like when we put all of that together? Well, we can imagine we've got some possible worlds. Let's just think of them as blobs out in logical space, and then we're going to evaluate sentences relative to them. So let's just take the simple logical case, and we've got some letters P, Q, and so on. So let's just suppose that we've got P true here, Q true here, maybe some more P's around here, and some more Q's around here, and maybe over here we just don't put either of them. So what we're saying here is P is true, but Q isn't. Let's have somewhere P and Q are both true, just for fun. So here we've got P true, but Q isn't there, so we'll say Q is false. Here we've got P true and Q true, so we can say P and Q is true. Here there's a P, not a Q, but still we can say P or Q is true, and so on. So each of these blobs, each of these possible worlds is doing basically the work of a classical truth table valuation. It's saying for each letter P, Q, it's going to be true or it's going to be false, not both, not neither. But we don't have to say that every valuation is represented here, okay? There might be some sentences like nothing is red and green all over in the same way at the same time, which on a classical truth table might be true, might be false, but we might want it to be true everywhere within our possible world semantics, okay? We might want to treat it as a necessary truth. Again, take something like nothing travels faster than the speed of light. In kind of classical logic, in a model, that might be true, it might be false, but we might want to say that it's true everywhere throughout these possible worlds to kind of capture the idea of capturing the laws of physics, making that necessary according to the laws of physics. Okay, so that is basically possible world semantics. It's some blobs, and we kind of throw some letters at those blobs and say those things true there, and then we work out all the other sentences that we might be interested in, whether they're true or false at some world. Okay, so that's the big conceptual change here. We're not just saying that P is true, we're saying that P is true there, but not true there or there. So truth now is relative to a world. We might think of one of these worlds as capturing our reality, so true in reality. Maybe it's that one, okay? So to say that P is true would mean that it's true there if we pick that one to represent our world. So we can still talk about truth and falsity, but the primary notion we're going to be working with here is truth or falsity relative to some possible world or other. Maybe that one, or whatever. Okay, so that's possible world semantics, but what can we do with it? Let's look at some applications. Maybe the most obvious application is to modal logic. So what we've got here isn't that far away from a model of modal logic, and that's where we've got sentences like box P to mean P is necessarily true, and diamond P to mean that P is possibly true, or it's possible that P. So what do we need for a model of modal logic? Well, really, we just need to add arrows, and these arrows are going to capture accessibility relations. Okay, so it means, for instance, that this world is accessible from this one, so's this one, and so's this one, whereas this world itself is accessible from that one. Okay, let's just stick a few more arrows on. We don't need to connect them all up. It's completely arbitrary what the arrows look like. We can have some two-way arrows, some loops. Okay, and then we evaluate diamond P as meaning true at some accessible world. So from here, what is possible? P, because that world's accessible. Also that one. And Q, because that world's accessible. So here, diamond P would be true. Diamond Q would be true. Also, because this world's accessible from here, and we've got both a P and a Q there, so P and Q would be true, we would have here diamond P and Q. Okay, so we can kind of combine all these different rules. What about the box for necessarily the case? Well, that's going to mean that P is true at all accessible worlds. So let's have a look again at this one. What's true at all accessible worlds? So we're looking at that world, and that world. Well, P's true at all of them. So we're going to have box P, necessarily P, true there. But we're not going to have, for instance, box Q because it's not true there or there. Okay, so there we have a really simple semantics for modal logic based on possible world semantics. Now, obviously we could say loads more about what possible world semantics can do as a logical semantics in the context of modal logic or other logics, intuitionistic logic, relevant logic. It's got loads of applications, but really I think we better leave that for another video. Let's look at another application, this time in philosophy of language. Let's think about propositions and what propositions are. Now, sometimes we use the concept proposition just to mean sentence or meaningful declarative sentence, something that's true or false. But often in philosophy of language, people think of propositions as something separate from sentences. I mean, sentences are things that you write down on pieces of paper. You know, different languages have different sentences, whereas propositions are what they express. Propositions capture our thoughts or the meaning of the sentences that we write down. So if I say, I'm sitting here, and then you say the same sentence, I'm sitting here, they express different propositions, right? Because when I say I'm sitting here, I express the proposition that Mark is sitting here. But when you say it, you express a different proposition about you, the proposition that you're sitting, okay? We use the same sentences, but different propositions. So there's probably a difference between sentences and propositions. And you know what? If there had never been any humans, if we'd never evolved, probably wouldn't have been any sentences, any thought. But there would still have been propositions, it seems, because it would have been true to say that there were no humans, no sentences. What would have been true? Well, it's probably the propositions that are true or false. Okay, so that's a bunch of simple arguments in the philosophy of language for thinking that propositions exist and they're different from sentences, different from episodes of thoughts. But what are they? Metaphysically speaking, what are propositions? How can we understand them? Or logically speaking, if we want to work with propositions, what kind of logical properties have they got? Well, enter possible world semantics. Let's go back to our diagram here. Forget the accessibility relations. Let's just have the possible worlds. We can think of or represent or capture or analyze the notion of a proposition just as a set of possible worlds. Okay, so for example, here are a bunch of worlds where P is true. That is all the possible worlds in this model where P is true. Let's take that to be the proposition that P. Okay, so the bit I've circled there, let's call that the proposition that P. And similarly, here are all the worlds where Q is true. Let's call that the proposition that Q. So we've got propositions as sets of possible worlds. It's super simple because once you've got possible worlds in your philosophy, and you've probably got sets in your philosophy, you don't really need to add anything extra to get propositions. They're just formed out of possible worlds. It's a very, very natural theory from the point of view of logic, because often when you do formal logic, you want to consider the set of things that make this thing true, or the set of things, if you like, which give you value T or value 1 when you ask the question. So the set of things that give you that answer, in this case, it's just going to be what we're calling the propositions. You ask a question, is P true or not? This is the set that gives you the answer. Yeah, it is true. Let's just identify that with the meaning, the proposition expressed by P. Okay, so meanings on this view are basically just functions that give you the answer true in certain circumstances. One of the nice features of this theory from a kind of logical point of view is it gives us a very easy, simple account of how propositions combine with the connective. So what is the proposition P and Q? Proposition P or Q. So let's just look at this. So we've got here the proposition P, we've got here the proposition Q. What would be the proposition P and Q? Well, it would be the worlds where P and Q are both true, and that is just the overlap of these two. It's the intersection of those two sets, okay? So, and on propositions just turns out to be intersection on sets. What about P or Q? Well, that's going to be the set of worlds where either P is true or Q is true, and that's just the union of those two sets. Okay, so union gives us disjunction on propositions. What about something like not P? Well, if here's P, not P is going to be these plus these. I haven't drawn that very well. So not is just going to be the complement of the set. So looking at all the possible worlds, if those ones are the P worlds, then all the rest are going to be the not P worlds. So negation on a proposition is just going to be the complement of that set. Let's take another example, this time in metaphysics or philosophy of mind, the notion of supervenience. So a lot of people in philosophy of mind say that the mind supervenes on some physical stuff like my brain or my whole physical body. And that's often offered as a definition of physicalism about the mind. What do we mean by physicalism about the mind? Well, specifically we mean that the mind supervenes on the brain, the body, or whatever. What does it mean there? What does supervenience mean? Well, roughly the idea is there couldn't be a change in my mind without my brain or my body changing in some way. So, nothing happens in my mind without a corresponding happening somewhere in my brain. Putting that more precisely, okay, the idea is it would be impossible for some difference in my mental state without a corresponding difference in my physical state. So we're talking about a modal notion there. It would be impossible for one thing without another. Okay, so supervenience is ultimately a modal notion, and we can capture that with possible worlds. The idea is take any possible world which is exactly physically just like this one. So in that possible world, my brain, my body, the whole physical world is doing exactly what it's doing. Then mentally, that possible world would have to be just the same as mine. So that kind of captures the idea that if you fix the physical stuff, you thereby fix the mental stuff as well. Of course, if you think that that's not the case, if you think that there could be some possible world where the physical stuff is just the same as this, but the mental stuff is different, maybe there's these kind of philosophical zombies, which are physical duplicates of me, including all of my brain, but they don't have any mental states at all, like David Chalmers talks about, then you're saying that the mind doesn't supervene on the brain, okay? So you wouldn't be a physicalist. The point here isn't that we're arguing for physicalism or against it or whatever. The point is, using possible world semantics, we have a very precise and neat way of articulating what we mean by physicalism and what it would be for physicalism to be true or false. That's a very helpful diagnostic tool to have in tricky philosophical conversations, like when we're trying to work out what the mind is. Okay, so that's all great, but, before we get to the but, let's just hover on the that's all great. It really is great. Possible world semantics really is one of the success stories of philosophy, since the 50s. It's made a huge contribution to formal logic, philosophical logic, theories of truth, the mind, metaphysics, philosophy of language. It just keeps going on, and it's one of the few philosophical theories that has spread from philosophy to, computer science, artificial intelligence, economics, maths. It's not often that philosophers get to influence other disciplines in these ways, so it's a real big achievement. Okay, that said, we're going to get on to some of the issues for possible world semantics. One of the issues is that it's not a very discriminating theory. So let me just give you an example of that, again with the idea of propositions. So we said in this example that there's the proposition that P, there's the proposition that Q, P and Q would be that one, P or Q would be all of those ones together. Okay, so what about P or not P? Well, P is here, and not P is all of the remainder, and or just puts them all together, so P or not P is all of the possible worlds we've got there. Okay? What about Q or not Q? Well, there's Q, there's not Q, Q or not Q puts them all together, so it's all of them again. So, P or not P is the same proposition on this view as Q or not Q. It's just all the possible worlds. Similarly, if we took a contradiction like P and not P, okay, well, there's P, there's not P, and is the intersection, that is none of them, so the proposition that P and not P is just the empty set. But exactly the same argument goes for Q and not Q. So any contradiction on this view is just the same proposition. All tautologies mean the same thing, all the possible worlds, and all logical contradictions mean the same thing. The empty set, no possible worlds. And you might think, well, yeah, there's a sense in which all contradictions are the same and all tautologies are the same. But there's a sense in which they're not. They don't seem to mean the same thing. They don't seem to be about the same thing. One way of making the case for that is, well, I could believe one and not the other. Okay, so maybe not, P and not P, Q and not Q, but take something really simple in maths, like 1 and 1 is 2, and then take something super complex, like Fermat's theorem or something like that. Something that you might not know, those things are just as true as each other and they're mathematically necessary. So each of them is going to be the same proposition according to the possible world semantics, yet you might know one and not the other. How are we going to reconcile that with the view that what you know is a proposition? I mean, if you know one but not the other, it looks like they're different propositions. So there's some tension there. A different way to put the argument might be they're about different things, or they're made true by different things. Okay, what makes I'm either sitting or not sitting right now true is the fact that I'm sitting. What makes either it's raining or not raining right now true is the fact that it's raining out there. They're about completely different things. One's about me, one's about the weather. They're made true by different things. How can they be the same proposition? Possible worlds, they don't divide things up, logical concepts up very finely. They're a bit coarse-grained. Technically, the terminology here is that this is an intentional semantics, okay? Intentional with an S. And that basically means that we're considering functions from possible worlds to truth values such that it respects logical equivalence, okay? If we've got P and Q, which are logically equivalent, this kind of semantics won't differentiate between them. On the other hand, a hyper-intentional semantics is one that can distinguish between logically equivalent contents. So, for instance, 1 and 1 is 2, Fermat's last theorem, you might believe one but not the other. Belief there would be a hyper-intentional concept. Okay, so assuming that there are genuine hyper-intentional concepts out there, does that mean we have to just get rid of possible world semantics? Well, some people do. They say, that's it for possible world semantics. But I think a better approach, considering how useful and influential possible world semantics is to see if we can tweak it slightly. So one approach would be to add to the domain of possible worlds also some impossible worlds, and maybe here we allow P and not P to be true and Q and not Q to be true, but maybe they're at different places, okay? So if we've got one impossible world that makes that contradiction true, but a different world that makes the contradiction with Q true, we could then say that these are different propositions. So basically, where possible worlds, we said they have to be complete and consistent. Impossible worlds, we might allow them to be inconsistent. We might also allow them to be incomplete, like they could be partial. An incomplete world might say, I'm sitting here, but say nothing at all about what you're up to. So worlds like this, the inconsistent and incomplete ones, you kind of see them in semantics for things like relevant logics, paraconsistent logics, and so on. So basically, possible world semantics, super useful, super influential. One or two little problems, and there's probably some good ways that we can tweak the system to overcome those problems. I find this stuff super interesting. There's been a whole load of literature on possible and impossible worlds and hyperintentionality recently. If you're interested in diving into some of that, go and look at the book I've linked to below. It's a book I wrote with Franz Berto, and it's open access, i.e. you can read the ebook for free. I hope you found this useful. If you want to say thanks, you can buy me a coffee over on Ko-Fi, or if there's a particular topic you'd like me to talk about, you can go and put a request at Ablebees. Thanks so much to all my Ko-Fi supporters for making this content possible, and thank you to you for watching this far. I really appreciate it. I hope to see you back at Attic Philosophy soon.